Assalamualaikum and a very good morning to all of you. Today is my turn, to continue with our lecture in basic engineering, engineering mechanics, Today's lecture is about the equilibrium of rigid body in 2D, This is the last part of the engineering mechanic for static. It's a 1.6, 1.6, the last subtopic for engineering mechanics. The learning outcomes of this subtopic include to describe the concept of rigid body in an engineering practice, B, differentiate between a particle and a rigid body, and C, solve the force system by using the concept of rigid body equilibrium. What are the previous knowledge that you must acquire, in order to solve the problem in this subtopic? First of all, the force in the force system that you have learned before, you need these skills, of force resolving. This is a very important skill, a fundamental one in the static. Number two, you need to acquire a skill or knowledge of constructing the free body diagram of the rigid body. Number three, you need to know how to calculate or do a summation of moment about a point. This is what you learned before in the subtopic moment. And also, the equilibrium of particle. The knowledge of the equilibrium is now going to be used for rigid body. So it's similar to what you have learned in equilibrium of particle. The first outcome is to describe the concept of rigid body in engineering practice. As you can see on the picture given, there are two types of product or structure. On the left side, given there is image of a bridge. Bridge is a large construction, a large product in engineering. So a bridge is used, to transport, for transportation, to connect from one place to another place. So in order to support various type of loading, or of people, vehicles, and so on, include the weight of the bridge itself. It must be supported. It must be supported firmly, by certain structure. So you can see at the bottom side of the bridge, there are large structure here. Many structure need to be engineered to support the bridge, as it have a loading on it. So this is the support that we use, in order to maintain the equilibrium or to achieve the equilibrium, so that the bridge will stay in static. There is no motion on the bridge, so people can pass over safely. So rigid body can be defined as idealized extended solid, idealized extended solid whose size and shape are definitely fixed and remain unaltered when force are applied. A body referred to a rigid body is currently stationary. The body which is currently stationary, like we see in the picture for the bridge, for example, we take a bridge as an example, it will remain stationary, if the resultant force and resultant moment are zero for all the forces and couples moment applied on it. So this is the condition for equilibrium of a rigid body. So now let us take a look on the next picture. This is the image of a crane. A crane used to lift an object, mostly a heavy object. In the construction and in industry. So this crane have a rigid body that attached to two types of support. Okay, so where is the rigid body actually? Rigid body is represented by this part of the crane. This is the rigid body of the crane. Okay, and then it is supported at two places. Okay, the first one, cable. Okay, the cable is used to support, okay, to support the load. Okay, and on the body of the crane, it use kind of link. Okay, this is short link or types of link. Okay, that support at the bottom part of the rigid body. So both support will prevent the motion of the rigid body so that the operation of lifting can be done properly. Okay, so that's example, okay, in real life of what the equilibrium of rigid body will look like. Okay, so it is highlighted here that a body that is currently stationary will remain stationary. Okay, if the resultant force and resultant moment are zero for all the forces and coupled moment applied on it. Okay, next outcomes is to differentiate between particle and the rigid body. Since that you have learned the equilibrium of particle, okay, and on the previous subtopic, so there is a relation between particle and the rigid body actually. Okay, a body of negligible dimension is called a particle. Okay, so particle has no dimension and shape. Okay, it is known as a dot. Okay, just a dot or not on the force system. But actually, particle has mass. Okay, if we count a number of particle, okay, it will become a body that has a definite shape, and therefore, when we combine a large number of particle, okay, they will become a rigid body. Okay, so a rigid body is the combination of a large number of particle which occupy fixed position with respect to another both before and after applying a load. Right? So this is a rigid body definition when we relate to the particle. And the last one is a rigid body may be defined as a body which can retain its shape and size even if subjected to some external forces. Okay, this is similar with what we have looked before. Okay. Okay, here is the comparison. Okay, we want to compare the equilibrium of particle and equilibrium of rigid body. Okay, there are given example on that. Okay, so particle is known as a dot or knot lie on the Cartesian. In the example, you have four forces F1, F2, F3, F4, okay, act to the particle. So this is similar to what we see in the concurrent force system. For equilibrium of rigid body, the equilibrium is achieved when the body or the rigid body, okay, is support by different types of support. Okay, so there is support reaction acting on this system. Okay, so and the force applied on the rigid body, okay, is in the coplanar types. Okay, 600 Newton, 800 Newton, and then there's a couple moment 900 Newton meter. It will act along the body. Okay, and different place or different location on the body. Okay, so here we have a body to be analyzed. Okay, compared to particle, we do not have a body. There is no shape and size on that. So for the conclusion of this comparison, we can conclude that the equilibrium of particle is made up from one point only. It has no dimension like a point in geometry. And the third one, in particle, the force is not subjected to moment. Okay, the force in the equilibrium of particle, okay, do not produce a moment. Okay, as there is no shape, so there is no dimension and no perpendicular distance. So the equation of equilibrium that can be applied here is only summation fx equal to 0 and summation fy equal to 0. Two equation. Okay, compared to equilibrium of rigid body can be in any shape. Okay, and in rigid body, dimension is very important. So when dimension is very important, it is consider the length and so on, the size. Moment will be produced by the applied force. So moment is now produced. And the equation of equilibrium will add one more. Okay, it will be three equation of equilibrium. Summation fx equal to 0, summation fy equal to 0, and summation moment equal to 0. Okay. Okay, now we move to the last objective of this topic. We want to solve the problem. Okay, solve the force system using concept of rigid body equilibrium. Okay, support reaction. Okay, the term of support reaction is very important. Okay, now the support reaction has become important element. Okay, when you want to solve this problem. So you need to recall that. Okay, that all the support reaction that you have learned in subtopic 1.3, if I'm not mistaken, 1.3 is FBD. So you're going to construct a proper FBD in order to solve this problem. So recall back, this is the first one. Okay, the first type of support reaction, this is cable type. Okay, cable type. So it will be the support reaction, the reaction will be represented, okay, like this. Okay, we just replace the cable with the reaction force. Okay, same direction. Next is the pin support, the most popular one. Okay, so the pin support will exerting two forces or two unknowns, force in x direction and force in y direction. Then we have roller support, rocker. Okay, this is roller support, this is rocker support, this is smooth surface. All this support, okay, will produce same reaction forces. Okay, it will produce only one unknown. Okay, the unknown or the reaction will be directed normal to the plane. Okay, normal to the plane of the surface of the contacting surface. Okay, like this. Okay, next. Okay, this is what we call fixed support. Okay, fixed support always will be used alone. Okay, fixed support doesn't need another support in the system. So fixed support can stand alone because it will produce the most unknowns in this equilibrium system. Okay, it will produce three unknowns, which are force in x, force in y, and moment reaction. Okay, and then we also have this type of support. This is short link or weightless link. Okay, short link and weightless link will behave similar to what we have in cable. Okay, similar to cable. Means that we just replace the link. Okay, the link here, the link with the reaction force, same direction. Okay. And many more support, okay, available in the equilibrium of rigid body. Okay. All right. We move on the process of solving. So the process of solving rigid body equilibrium, okay, include three main steps. Okay, the first step is actually to converting from the physical system of the rigid body to an idealized model. You want to separate it from the surrounding. Okay, so the picture that you see here is a physical system. Okay, physical system of the rigid body. Okay, so which one is a rigid body? Okay, as we defined before, rigid body is an extended shape solid. So, and it's being supported by many types of support. Okay, so here we can define that this is the rigid body. So now we want to idealize in 2D view. Okay, so it can clearly seen, right? like this. Okay, so this is an idealized model. We separate it from the tower. Okay, so this is the rigid body. Draw it. We simplify the body. Okay, this is box shape. Okay, the box shape body. Okay, being support at point A and the top, and then point B is supported by cable. So here it used two supporter. Okay, this is cable. Then this is pin support. Okay, so this is into the view, so it can be seen clearly. So next step is only we can construct the proper FBD from that model. Okay, so now we can draw the free body diagram showing all the forces acting. Okay, and we can put the reaction force, okay, at pin, cable, and all the dimension given. So after this, then we can continue with the solving process, okay, with the equilibrium or equation of equilibrium. Okay, so going to use the summation Fx equal to 0, summation Fy equal to 0, and summation moment equal to 0. Okay, right. So we move on the next step, analysis. Okay, now we move to analysis. So analysis of the equilibrium of rigid body include two main steps. Okay, the first step is free body diagram itself, and the second one is the equations of equilibrium. So this is similar with what you have learned. Okay, we just recall back the step. For FBD, we draw outline shape of the body, establish the x-axis and y-axis, and then show all the forces acting on the body, including the couple moment, and then show all the reaction forces, including reaction moment, if any, and specify their direction, and then we indicate the dimension of the body. Okay, that's the step for a free body diagram. Okay, the second step is equation. So equation, okay, there are three equations to be used. Okay, but normally, we will start with the equation of moment. Okay, summation of moment about a point equal to 0, always being used as the first equation, because this equation actually can solve for unknown. Okay, sometimes we have more than one unknowns at one point, so we need this summation to eliminate the both unknown. Okay, to get into the other unknowns. Okay, we will look in detail later. Okay, for this, and then we can okay, we apply the summation fx equal to 0, and lastly summation fy equal to 0. Okay, notice that in the final step, okay, when you get the result, sometimes you will get the negative scalar. Okay, if you get the negative scalar, it doesn't mean that you are wrong. Okay, it just means that the sign is opposite to what that was assumed on the FBD. Okay, because in FBD, all the reaction force, okay, or reaction moment that we put on the FBD can be assumed. Okay, can be assumed. So sometimes the assumption is correct, sometimes it's not correct. So, but it doesn't matter. Okay, the important thing is you get the final result, and then you give, you state back the real direction or the correct direction. Okay, we moved on to problem 1. Okay, determine the horizontal and vertical components of a reaction. So this is a typical question, okay, used in rigid body. Okay, a typical statement. Determine the reaction. Okay, it can simplify the question like determine the reaction, but this question are using full statement, complete. It guides you, to find the components. It mentioned here. It mentioned already the component horizontal and vertical. So in Cartesian, okay, in the xy axis, horizontal represent the force in x direction, and vertical represent the force in y direction, horizontal. Okay, X, vertical Y axis. Sorry. Oh, sorry. Okay, never mind. Okay, so what are the support that being used in this system? Okay, it mentioned here. Okay, if you can look closely at point A, it used rocker. This is rocker support. Okay, rocker support. And at point B, it used pin support. Okay, pin support. So pin support always be paired with other support like rocker, roller, or anything that provide one unknown or one direction normal to the plane. Okay, this is what the typical question of rigid body. And then you need to carefully read the last part of the question. Okay, the last part of the question usually it will give you the information about the weight or the thickness, because the rigid body have shape. Okay, rigid body is made from X and Y translation. Okay, it has a, so sometimes we need to consider the shape, sometimes we need to consider the thickness, sometimes we don't need. Okay, so that will be mentioned in the question. So the question mentioned here, neglect the weight of the beam in the calculation, but it doesn't state to neglect the thickness. Okay, and here it gives the half of the thickness 0.2 meter. So in this question, you cannot neglect the thickness, but you can neglect the weight. So the weight of the beam is neglect, so we don't need to put W, okay, to represent the weight. Okay, so W is omitted in this problem. Alright, so according to the process before, the first process is start with the constructing the free body diagram. Okay, free body diagram. The main purpose of that is to convert the support here to its reaction. What types of reaction occur at point A when it's used rocker, and what types of reaction occur at point B for pin? So that's the main objective of constructing the free body diagram. Okay. So we know that for rocker, it will produce one reaction force, okay, that go in the direction normal to the plane, and at pin we have two reaction force. Okay, actually it's component of force. Okay, we have Bx and By, two unknown here. So here we will replace with Bx and By. Okay, and both are assumed. Okay, the direction we can assume. Here only have A in Y direction. Okay, we use A because the point here is A. We use B here because the point here is B. So it's easier for us in the analysis or in the equation later. Okay, so in a proper drawing of FBT, okay, now we're going to check one by one. Okay, one by one what happened to the rigid body when being applied with three forces. Okay, this rigid body is applied with 600 Newton with 45 degree to the x-axis, and then 100 Newton vertical, okay, downward, 200 Newton, okay, the vertical load also downward. So we have three. You can see there are three action forces. Okay, the first one, we start with 600 Newton. Okay, 600 Newton here, it can be represented by its component. Okay, so now we have to resolve the 600 Newton into its component. So it have Y component directed downward, and it have X component directed to the right. Okay, directed to the right on x-axis. So we need to apply this component in order to make us easy to solve the problem. Okay, and then 600 will not be used in the analysis. We're going to use the the component only. So here is 600 sine 45. This is 600 cos 45. So this one can be cancelled. So we have two forces here. So repeat that. Okay. So actually now we have 4 action forces. Okay, 1, 2, 3, 4. So these all 4 forces actually will give an impact or will have effect on the point A and point B of the body. Okay. Okay, I start with 600 cos 45. 600 cos 45 will be directed to the right, So it try to move the body to the right with the force of 600 cos 45. So now both reaction at A and B must produce reaction to oppose that force, okay, to achieve the equilibrium. So which support can provide that reaction? Is it A or B? Yes. Support at B will provide that opposition force or reaction force to counter back the 600 cos 45. Okay, it will react to the left, okay, with Bx force. So Bx force will act as a reaction force to the 600 cos 45 degree, and it will give the same value of force but in opposite direction, so that equilibrium in x direction can be achieved. Okay, now we look on the y direction. Y direction for action force provided by 600 sine 45, 200 Newton and 100 Newton here. So all the 3 forces actually directed downwards. So it tried to move this object or this body downward with the force of 600 sine 45 plus 100 plus 200. There are a lot of forces here. So so can A and B counter back by giving reaction, okay, to support the body? Of course can. Okay, because A provide reaction upward, okay, with AY, and B provide reaction upward with BY. So both AY and BY, okay, the total of AY and BY will be similar to the total of 600 sine 45, 200 and 100. Okay, same magnitude but opposite direction. So one more time, the equilibrium can be achieved in Y direction. Okay, so for X and Y, it's clearly see here that equilibrium is achieved. So I'm going to continue with the explanation. Okay, so now, so here is the graphical of free body diagram. Okay, this I will represent the action force with the red color. Red color arrow here represent all the action force or apply force. Sorry, apply force. Okay, then 200 Newton apply force or action force act on the beam at B in Y direction and is independent of the force component. Okay, independent of the force component mean the 200 Newton only exists in Y direction. So the component of Fx is equal to 0 lah. Okay, so it doesn't need to resolve. You just put 200 Newton downward. Okay, okay, Y direction. Next is 100 Newton. 100 Newton, the force here. Also same with 200 Newton, it will act downward, okay, in Y direction. So we don't need to do anything, just put it like that. So now we have 4 action forces, sorry. Okay, so all the red color represent action or apply force for this system. Okay, now, so what happened now is point A and point B that being support will counter back with reaction force. Okay, firstly we start with AY. AY represent the effect of the rocker on the beam. Now AY will be exerted by the rocker, okay, to oppose the action forces. So here is the green color. Green color force represent reaction force. So now here we have AY, okay, for the first reaction at point A. And then at point B, we have two reaction forces. We have BX and BY that represent the effect of the pin on the beam. Okay, now BX and BY. Okay, although we can assume, but now that I have shown you, we did a little bit of analysis that this direction is actually the real direction of the BX. Okay, because it only have one opponent here. Okay, 600 Newton cos 45 is an action force. Okay, so it will oppose Bx as a reaction force. So both will have the same magnitude but in opposite direction, in x direction. Okay, that's so settled. For force in x direction, you can settle it easily. Okay, we don't need to count it. Okay, the value of a Bx now is truly 600 cos 45. Okay. Okay, next we complete the FBD. Okay, here is distance. Oh, sorry. Okay, so here is distance. Okay, I will label. Okay, now we will label all the forces. Start with 600 sin 45. Okay, here is 600 cos 45. Here is 200 Newton, 100 Newton. Okay, then the green force is reaction force. The first reaction AY, BY, and BX. Okay, and then not forgotten the dimension of the body. Okay, the thickness here is 0.2 meter. The length here is 2 meter. Length here is 3 meter, and the length here is 2 meter. So we need to draw a proper complete FBD, okay, to make sure that we can get a maximum mark for this step. Okay, actually I want to do it manually, so I'm going to use other types of file. Okay, I will repeat back the step. So here is 600 sin 45, 600 cos 45, 100, 200, okay, and then the reaction here is AY. Okay, I will use the same color with the force. Okay, AY, here is BY, and here is BX. Okay, and then we have the dimension of the body is 0.2 meter. Meter, 2 meter, 2 meter. Okay, so the FBD is complete now. So we next going to apply the equation of equilibrium. Okay, the equation of equilibrium. Okay, equation of equilibrium. Okay, before we proceed with the equation, I will add some explanation about the moment. Okay, how the moment react in this system. Okay, we can only see before how the force react at both support A and B to the applied force, but we cannot see clearly how the moment will react in this system. Okay, so moment has okay, as you have learned before, the moment need these two components, F and D. So here, okay, you have 4 apply force. Okay, and you have 2 point of 2 critical point where the supporter is attached to the body. So point A and point B. Okay, so this is case where I'm going to use all the action force. Okay, action force. Just want to show you what is happening now. Okay, let's say we are summing moment. Okay, we are summing moment at point A. Okay, point A. Okay, summing moment at point A with the assumption of clockwise positive. Okay, now I will list all the components. So we have this component. Okay, this value, this 600 sin 45, 600 cos 45. Okay, so all the forces, okay, can produce moment at point A. Okay, can produce moment. So we can get the summation of the moment at point A. It will equate to something lah. Okay, we can get value of moment at point A by considering all the action forces here. Okay, so we have, for example, we have first one. Okay, first component here will produce clockwise. This one also produce clockwise. Okay, this one produce clockwise. Okay, as you can see, all the 4 forces will be produced clockwise moment at point A. So it will give quite a large number or large amount of moment at point A. Let's say the value of all the forces that produce moment equal to 1000 Newton meter. Okay, example is not the answer, but let's say the answer for summation moment at A equal to 1000 Newton meter. Okay, and it will rotate clockwise. Okay, it will rotate clockwise. So what happened in the body if it being acted by this amount of moment at point A? So we're going to use the same point A, but now I will consider the reaction force only. So here we have A, Y. Here we have Bx and By. Okay, all the action forces is neglected in this case. Okay, okay. So this is a distance. Distance is 7 meter. Okay, now we are taking moment at the same point. Summation moment at point A, so equals to. So first of all, the force Ay will produce 0 moment at point A. Okay, Ay will times 0. Okay, because Ay will be directed with the same line of point A, so the distance will be 0. So the only reaction force that will produce the moment at point A is By. Okay, Bx also will be the same case with Ay. Bx also will act with the same line of point A. So Bx times 0. So we only being by By. Okay, so By times 7. Okay, By times 7 will produce moment in the direction of anti-clockwise, counterclockwise. Okay, so that's the only moment that produced by the reaction force at point A. And notice that this is what the opposite to 1000 Newton meter. So we will get summation moment at A by reaction force equal to 7 By Newton meter counterclockwise. So by equilibrium, to achieve the equilibrium, this moment will oppose this moment. Okay, so this is reaction. This is action. Okay, action, black color action. So now we are in the scenario of action versus reaction, because what we are doing in this topic is we are applying the theory of Newton's third law of motion. So in a proper way, we can write down, okay, the relation between both. So I repeat, this is action, this is reaction. So 1000 Newton meter must be equal to 7 By Newton meter, so that the equilibrium of the rigid body can be achieved. So this is what happening to the rigid body. So now we can get the value of By. By using this equation, we can get By equal to 1000 divided by 7. So we get the actual value of force By. So that's why in this case, we use two types of support. Okay, there are two support, one on the left, one on the right. Okay, pin support always be paired with other support like roller, rocker, and so on. Because of what? Because we want to we want to create a force that can produce moment or produce a reaction moment to fight, to counter back with the moment produced by the action forces. Okay, so that's all for the explanation of the equilibrium. Okay, I just explained to you what happened in force X direction, in force Y direction, and in moment direction. So now we can rest assured we can apply the three equation without any doubt. Okay, all the equation has been proved here. Okay, and we are proving the theory of Newton's third law of motion. Every action has its own reaction with the same magnitude but opposite direction. Okay. Okay, this is the proper answer for equation of equilibrium. Okay, here is start with summation Fi equal to 0 because this is the most simple one. This is there's only one. There's only two components in X direction. One component for action forces. Okay, then one component for reaction force. So Bx or the reaction force will be equal to will be exactly same with the action force. 600 cos 45 equal to 424.26 Newton. Okay, so check. Done. Next, here it apply the summation Fy equal to 0. Okay, you can use this sequence in the real situation. It doesn't. Okay, it's okay to use this sequence even though that the second equation will be stuck at here. Okay, it's okay. So summation Fy equal to 0. So the component of Fy, okay, just like I explained to you just now. Okay, we collect all the force, okay, in Y direction. We all collect all the force, whether it is reaction or action, okay, in one full equation here, so that we can find, or we can solve for the unknown. Okay, so we have AY, okay, AY here, AY plus BY, okay, must oppose to these three forces. 600 sine 45, this force, 100, this force, 200, this force. Okay, two force fight with three force. Action versus reaction. So from this we can get AY plus BY equal to 724.26 Newton. So this is the KIV step. Okay, okay. We stop here because we cannot solve for both unknown. So, and we have one more equation to be used, which is the summation moment. Okay. So here it use the summation moment at point B. Okay. Why you use point B instead of A? There is a reason why you choose to summing moment at point B. As you can see here, point B have two unknowns, Bx and By. Let's say, okay, we're going to apply this moment equation on the first step. Okay, if you're going to apply this summation moment at the first step, okay, we always choose a point where it has most unknown. So point A and point B, compare with A and B. Okay, B have most unknown here. B have Bx and By. So when we taking moment at point B is exactly at this point. Okay, so point B, there are two force acted concentrate to point B, By and Bx. So when we are taking moment at point B, both Bx and By can be eliminated in the equation of moment. So we can manipulate this situation to eliminate Bx and By in the equation of moment, so that we can only focus to find on the other unknown, which is Ay. That's why it is point B. But if we follow this sequence, actually we don't need to choose point B. Point A also can. Okay, you can use summation moment at point A because we already obtained the value of Bx here. So Bx is not an issue. Okay, you can use, and furthermore, the Bx force is is directed with the same line of point A. So it doesn't affect on the amount of the moment. Okay, we can still take moment at point A, and Bx will produce zero moment also. Okay, so this is come from practice. Okay, if you practice a lot, you can know which equation to be applied first. Okay, what unknown to be getting first. Okay, to simplify your the whole solution. Okay, so now by doing maths, okay, substitute there and there, you can get the Ay and By. Okay. Oh, I'm taking quite a long time to explain to you in problem 1. So we continue with problem 2, guys. Okay, problem 2. Okay. So here is link. Okay. The body here is use a type of link. The link in the diagram is pin connected at A. Okay, pin connected at A here. Okay, so use pin support, and then rest a smooth support. Rest a smooth support at B. Where is B? B here. So B use smooth support, smooth contacting surface. So it will produce one unknown. So B smooth support. And so compute the horizontal and vertical components of traction at A. So you need to find at this point the unknown force of Ax and Ay. Okay, first thing first, FBD. So without wasting any time, proceed with the free body diagram. One more thing. Here it gives you extra information, not extra information. This is what we call couple moment. Okay, sometime in the rigid body equilibrium, okay, it will consider amount of couple moment that act on the body. So we will indicate like this arrow, okay? Moment unit Newton meter, and it will be shown as a rotation, okay? Rotation of arrow either in clockwise or anti-clockwise. So this is couple moment. Okay, we have 60 Newton force for the action force, and we have couple moment of 90 Newton meter as a action couple acting on the body. And we have two type of support. At point A, pin support. At point B, we have smooth surface, smooth support. Okay, so here we have AX and AY, and here it will exerting one unknown normal to the plane. Okay, this is point. This is force B. We cannot use BX or BY because this is not lie on the X or Y axis. Just use B or FB or whatever. But you cannot use X or Y because it's not in X or Y direction. So we construct the FBD. So FBD, the body, the link, okay. And there is no information about the weight and the thickness of the body, so assumed to be weightless and no thickness in this question category. So here is the moment, couple moment, 90 Newton meter, and then action force 60 Newton, and then reaction force, okay, AX and AY. So I will draw AY to upward and AX to the right, assume, okay. Don't want to waste any time, just assume the X to the right. Okay, I don't want to analyze like before. Okay, here is the normal force, okay, of B. Okay, normal to the plane. So we label here with force B or normal B. Okay, depends. Okay, so I want to use normal B. Okay, normal B. So point A, and then we include the dimension. Okay, this is 0.75 meter. Okay, this is 1 meter. This is 0.5 meter. Okay, that's all for the FBD. Okay, done FBD. Next equation. Okay, start with, no, wait, what the question one? I didn't read the question. Compute the horizontal and vertical component of reaction at pin A, okay? So we need to find AX and AY. Okay. To make it fast, let us do the summation of moment first for the equation. Okay, we start with summation of moment at point A. Because what? Because point A has two unknown that going to be eliminated. Okay, so summation moment at A equal to 0 for equilibrium. Okay, and then assume the rotation is clockwise positive. Okay, we start with NB first. So NB, okay, NB times 0.75 produce moment at point A here. So NB times perpendicular distance 0.75. And we rotate anti-clockwise, so it will indicate as negative moment. Okay, negative moment, NB 0.75. And then we take 60 Newton. 60 Newton positive 60 times 1, okay, time 1, okay, and lastly we put in the 90 Newton meter, okay, 90 Newton meter also have the same rotation, of what we assume here, so it will positive 90. Okay, check back all the component include on the equation, so all shall be equal to 0. So from this equation of moment, we can directly get the unknown of NB. So here we can get NB. Okay. So from that, we can continue with summation fx equal to 0 and summation fy equal to 0. Okay, to solve for the ax and ay. Okay, I am running out of time now, so I think I will stop here. Okay, so this is the full equation of the equilibrium rigid body. Okay, this is the full full version of the equation. Okay, here MA equal to 0, moment summation Fx equal to 0, summation Fy equal to 0. So first step we get NB, and then second step we get AX, and the third step we get AY. Okay, so I will stop right now. Okay, thank you for your cooperation. I hope you will continue to further your study, okay, with plenty of example that being provided in your books. Okay, so please look carefully on that example just to see what types of support that being used. Okay, you have get to be familiar with all type of support, because we don't want to waste our time in constructing the FPD. Okay, and then also please do a lot of exercise to make sure that you can do the summation or the equation of equilibrium, okay, correctly. Okay, so thank you guys. So we'll see you again. Assalamualaikum.